Alright, this is my third part of third video, third part, whatever, of how to solve a 3x3 Rubik's Cube blindfolded. I'm going to be teaching you how to solve the edge permutation. Um, oh, by the way, I told you there's four parts: edge orientation, corner orientation, edge permutation, corner permutation. You cannot do the permutation first. You have to do orientation first, because then it won't work. And you can do orientation of edges and corners. You can do corners or edges first. It doesn't matter. And when you're doing permutation, you could do either. It doesn't matter. Okay, so see, you have the cube, edges and corners oriented. If there aren't, then you should go back to my videos, learn how to orient the edges and reorient them, and then come back and have the cube in the same state as mine, same scramble. After I did all that. Okay, so uh, um, so um, there are algorithms to orient to permute the corners and edges, but there isn't like a but it's more thinking. Like, you don't just have a fixed algorithm. It is a fixed algorithm obviously, but you don't like use one algorithm for every piece. Like, you might use a different algorithm to permute. Alright, so you have on the blue, red, white side, you have yellow, green, orange. So yellow, green, orange has to go to yellow, green, orange. Oh, sorry for saying that. Has to go here. This piece has to go to yellow, blue, orange. That piece has to go to yellow, yellow, green, red here. Sorry. And that piece has to go up. And then this piece has to go to the right. That piece has to go diagonal. That piece has to go to the yellow, blue, red, and then that piece goes back to the original position with the first piece. So that's 2, 3, 4, 5, 6, 7. So that is 7 pieces. That is a good thing. Tell you why right now. It is because if you have an even number of pieces, you're going to end up with something called parity, which I'm going to teach in a later video. Okay, parity is an annoying case because you got to take all the edges that are still unoriented after you've done as many cycles as you can and orient them using a PLL algorithm. PLL means permutation last layer. It's a regular solve algorithm that you use. You have to memorize it. If you don't memorize it, you're not going to be able to use it. And you won't be able, because you'll have your blindfold on anyway during the blindfold solve. You won't be able to use the algorithm because you can't see it anyway. Okay, so let's see. Okay, so for corner permutation, you gotta remember one thing. When you're doing a setup move, okay, there's setup move, algorithm, undo setup move. Okay, 3 things. When you're doing a setup move, you can move the top and bottom sides as much as you want. But the left, right, front, and back side, you have to move 2 times. I mean, you don't have to move it. If you don't have to move it, you don't have to move it. But if it doesn't require you to move it, then you don't have to move it. But if there is a case where you're gonna move it, you have to move it 2 times. So you can't just move this once and then permute. You have to move it twice. Okay, twice. So you can do to do the setup move, you can do L2U or L2D, but you can't do LU. Okay, you can do L2D D2 L2 D R F2. Okay, as long as you follow that rule. Because if you don't do that and you permute it, it's gonna end the one of the pieces that you permuted is gonna end up unoriented, as in corners, because edges won't be affected with this. Alright, so yellow, green, orange needs to go to yellow, green, orange. Yellow, blue, orange, yellow, blue, orange here. So this piece needs to go here, and that needs to go here. So here, here, here. So here, here, here. So you can move this up. That's okay to do. As I said, 2 times. Okay, so they'll have to move here to here to here because you moved it. You just set them, so it changes. So you switch it 2 times. Use algorithm. Bring it back. Change it. Wait, see, it works. See, now you permuted your first two edges, corners. Congratulations. Yellow, green, orange is in its correct position. White, yellow, blue, orange is in its correct position. Just look at the sides and you'll see the right piece. Okay, now yellow, green, red has to go to yellow, green, red, and that piece has to go up. So you can move D2, R2, do the algorithm, undo setup move, R2, D2. Now those two edges, those two corners are in its correct position. And remember, you will not get a parity on this case, sorry, because it's an odd number of corners, so you're not gonna get a parity. Oh, by the way, let me teach you this. If you have 1, 2, 3, 4, 5, and 1 has to go 2, 2, 3, 3, 4, 4, 5, 5, 1, right? So you have to do, so what I'm doing right now is, I just did 1, 2, 3, right? So 1 goes to 2, 2 goes to 3, 3 does not go to 4, 3 goes back to 1. Then you have to do 1, 4, 5, which I'm doing now. If you have a case where you have 7, I have only 5 to do. So 1 goes to 4, 4 goes to 5, 5 goes back to 1. So basically you're always using the first piece, and the other pieces you're switching off. You're not switching off, you're constantly moving on. So yeah. So if you have a solve, so that means that if you have a solve and you use one piece and suddenly on one of the cycles you realize you're not using that piece anymore, you did something wrong. Okay, so if you have to move these pieces and you move these pieces first, and then you realize you're suddenly moving this piece here, like that's not, and you're not moving this piece, then you know that you probably did something wrong because that's not the right piece. Or maybe you got confused and you haven't moved anything yet, so just don't move that piece, think again, and figure out how to do it. Alright, so that's a good advice, because if you do that and you screw up, you wasted however long you took to memorize, and you have to start all over. Unless you're super smart, and yeah, and you can memorize it in 5 seconds. Alright, so white, green, orange has to move to white, green, orange, and then yellow, blue, red, and that back. So that creates a cycle. That's actually an algorithm itself. So you don't have to do a setup move. The setup move is just nothing. You don't have to do anything. So this moves to here. So and it's even going in the right direction of the algorithm. That the algorithm goes in this direction. Okay, it's like kind of like a triangle if you look at the side of the cube. So this is the algorithm. Right. You hold it like you hold it so that the top piece that is, wait, hold on. You hold the blue, red, yellow piece closest to you. Okay, and yeah, you hold that closest. You hold that to your facing you to the right side and on top. So yeah, that will give you the orientation of the cube that you have to do the algorithm. So I mean I'm just giving you that example so you know next time. Oh, that's how you do it. You can figure it out yourself. So do L2 D prime L2 D L2 V2 L2 D prime L2 D L2 V2, and then remember you didn't do any setup moves. You don't have to do anything. Turn back. Now it's solved. So blue. So those corners are solved now, and that was a complete cycle. So I don't think there's any more corners you have to solve. So congratulations. You have solved all the corners. Congratulations. So you're lucky in this case. I'm gonna create a special case at like the 5th or 6th video or whatever. I don't know. Don't listen to me. Just in a later video. Not the next video. I'm gonna create a case where it's called parity. I told you already. Where the cycles didn't complete all the switching, and you ended up with an even number of. You ended up with a certain number of edges and corners, or corners alone or edges alone that you have to permute by themselves. Alright, so on to part 3, and yeah, thanks.